Hello everyone. In this video I'll be going over the second half of the GCR Postulates notes, starting with number 7, substitution. So substitution can appear in 4 different ways, 2 different setups, and then we've got it with the angles and with the segments. And remember, for this video I recommend you have some markers handy. I'm actually going to be using 4 here. So I've got 2 pairs, like one with very different colors and different shades, and then I'm just going to go back and forth between the 2, just to kind of separate my notes a little better. Okay. So substitution, I'm going to start with the top pair. They're going to look very similar, and then the bottom pair are going to look very similar. So let's say we're given that angle 1 is congruent to angle 2. And then let's say that angle 1 is also congruent to angle 4. So what you're looking for in an example like this that tells you it's substitution is you're looking for a repeated angle in each line. And we can see that repeat angle 1 twice. So, since we see 2 angle 1s, that means we have a substitution problem. So what I do is I like to box in the common angle, and then the 2 that are left, I'm going to say that those are congruent in my conclusion. So now my conclusion is angle 2 is congruent to angle 4. And my reason is substitution. I love to abbreviate this one. If you're going to do it like this, S-U-B-S-T. I mentioned in my last video that there's one very similar to subtraction. That's this one. The subtraction, remember, we do S-U-B-T. So those can get a little tricky. So make sure you're being very careful when you're abbreviating. If you're afraid that you'll mess that up, then go ahead and just write out the full word. I know it's a bit of a pain, but it will avoid mistakes. All right, let's look at that same idea, but with segments. So let's say we're given that AC is congruent to FG, and LM is congruent to FG. So those are both of my givens. Once again, we're looking for a repeated segment, and as you can see, that is FG, and they're both on the right side. So then my 2 remaining segments are AC and LM. So my conclusion, AC is congruent to LM. And then the reason is the same, by substitution. All right, let's repeat that again, but the orientation is going to look a little different. So let's say this time we're given that angle 7 is congruent to angle 2. And then we'll come down here and say that angle 2 is congruent to angle 3. So it looks slightly different, but the idea is still very much the same. We look for a repeated angle between the 2, and angle 2 is repeated. It's on both sides, or both statements. So we have angle 2 here and angle 2 here. So, because they're both congruent to 2 different angles, those 2 different angles are also congruent. That's the whole idea. I should have reiterated that from the beginning. So if we have 2 angles, they're the same angle, congruent to different angles, then the different angles are also going to be congruent. Hopefully the logic makes sense there. So my conclusion is the 2 remaining angles, angle 7 congruent to angle 3. And then the reason, once again, substitution. One more, let's take a look at it with segments again. So let's say we're given that CM is congruent to segment XY. And then let's say that segment TV is congruent to segment CM. Once again, you're looking for a repeated angle, here it's a repeated segment, and we are repeating segment CM in both spots. Since I've got that twice, this is a substitution problem, so the 2 that are left are also going to be congruent. So my conclusion, TV is congruent to XY. And then my reason is also substitution. Alright, so hopefully that made sense. This is actually one of my favorite postulates because it's the easiest to look for and the easiest to rule out. So if you're given a set of congruent angles or segments as you're given, look for this first because it's really easy to spot. And if you don't look for it first, it's also really easy to forget about. So ask yourself, do I have 2 of the same angle or 2 of the same segment? If your answer is yes, then you have substitution. If all 4 are different, then you don't have a substitution problem and you can consider other options. So I recommend looking at this first when you're doing a problem. All right, flip that on over. We'll come to number 8, the reflexive segment addition postulate. And let me just kind of zoom out here a little bit. We look at all 4 of these. They all start with the same word, reflexive. So these are kind of nice because you'll know them when you see them. You will see that your problem has 2 steps. This is 2 steps in each conclusion and reason on this whole page. So if you are given a problem and you have 2 steps for your conclusion and reason, you automatically know it's one of these 4 postulates. And then from there, we've got 2 for segments and 2 for angles. So it's really easy to narrow these down from there. Now, this is 100% visual, so hopefully you're able to see what I'm trying to show you. And this is why color coding is so important in these kinds of problems. So let's say my given here is that FG is congruent to HI. So first I'm going to color code. So remember, when you're given a problem, it's going to look like this, where you just got the given and your picture. The rest you have to figure out. So color code. Okay, so just like I've been doing this whole time with the last video, pick a color for this particular statement. I'm going to use blue. So, and I like to put the color next to it just so I can show you which color goes with what. So FG is this segment here. So that's blue. And then HI, I'm also going to make blue. So I do the color coding just so you can very clearly, obviously see, these are both blue, so they're congruent. Don't have to have any special markings or anything. Now, for the reflexive, this is what you're looking for. When I've got these 2 segments, you're looking for, do I have a segment, the segment in between is GH. So since I got the segment in between the 2, I'm going to go ahead and point out that it's the same segment between both. This is one of those things that you have to see it first. I shouldn't make that an A. I did 1 and 2 before, but when I look at like the test and the knowledge checks, they like to just say A and B here. So I changed this to A, B. Okay, so let's say A. This is our first step. We're saying that GH is congruent to itself. Now that seems a bit ridiculous and redundant, but there's a reason we do it. So this is the reflexive piece. Reflexive just means related to itself. It's the same thing as pointing out that 1 equals 1. It's like an obvious thing, but there's a reason why we have to do it. So our reason here is reflexive. So what I'm going to do, and this is the point of the postulate, is I'm going to take these two congruent segments, and I'm going to add the same segment to both of them. And then those new segments are going to also be congruent. That's the point of the postulate. So I have to make this step so that I am clarifying for whoever I'm telling this to that I'm adding the same segment to both pieces. If I added 2 different segments, that would obviously change things. So now what I'm going to do, I'm going to take my green and kind of highlight, okay, this piece is different, and it's in between the 2. So I'm just kind of, this is like me just pointing it out. All right, so for this piece, this has a little bit of work involved. So wherever you have space on your paper, since my space is over here, I'm going to put my space over here. But I highly recommend this when you're doing these problems, is you write out what you're doing, because it's really easy to get confused when you're just trying to do this all visually. All right, so I'm going to write down my 2 segments here. I'm going to write FG here, and write HI underneath it. I'm going to have 2 different equations. So FG and HI. Now I know that I'm adding because I've got this lone segment here that's not a part of either of them. You'll see this more clearly when I show you the subtraction one next. Now I'm taking the piece that I pointed out in step A, I'm going to add it to both of these. I'm going to put GH here and here. So as I reiterated before, I'm taking this piece, I'm adding it to each of these individually and creating 2 new segments. So let's look at these one at a time. If I take FG and add GH to it, what's that new segment if I have both of these together? FH. I hope you all can see that. FG plus GH is FH. Now I'm going to come down here and do the same thing with HI. HI plus GH is GI. So these are my new segments that I'm forming when I add these together. So now I just take these, and I'm just going to do this color here. These go into step B. So those 2 new segments, I now have FH is congruent to GI. And don't forget those segment symbols. I left them out of over here on purpose, just not to get into it, but mathematically speaking, this is the proper way to write it when I'm doing addition and subtraction. But if you put the symbols in here, it's fine. But make sure they're in your table. Okay, so FH and GI are congruent. And my reason, now, this is segments, so we got seg. Hope we can all see that these are segments. And then postulate I'm going to put here. Once you've narrowed your problems down, you'll be like, okay, did I add or subtract here? Hopefully the equations make it obvious. I added here. The segments got longer, not shorter. So segment, addition, postulate. Seg, add, post. All right, now let's repeat that with number 9, the reflexive segment subtraction postulate, and show you how they are the same. Or not the same, but show the big difference between the two. Okay, so let's say this time I'm given that FH, wrote FI, I don't know why. FH is congruent to GI. Here's a recommendation when you see a reflexive problem. You see your 2 steps. Go ahead and do yourself a favor and go ahead and fill in this reason as reflexive. You're going to see when I go through all of these that this is the first reason every single time. So that's nice. You get these are all worth 1 point on your test and your knowledge checks. So if you can get this one, that's one of the 4 points. Okay, so I just went ahead and did that. All right, now I'm going to color code. This time I'm going to switch over to my pink and purple markers. Okay, and I'm going to actually just use the purple for my coloring. So I'm going to make these purple. So FH. I made a video before about tips for these types of problems. My biggest tip is to preview before you color. This is going to be why. FH, if I follow, FH is here, and GI is here. Hopefully you can see there's going to be some overlap here. So I kind of want to create a little bit of separation so I can still see the 2 coloring. So I'm going to kind of hover a bit. So FH is staying right on top of the line. And then GI, I'm going to kind of jump down just a little bit so I can create a little bit of space so that I can see that clear overlap and they don't blend together too much. So FH, GI. Hopefully you can clearly see this overlap here. I'm going to use the pink to color that in. So I'm going to point that out, overlap. You see that overlap there? This will automatically tell you this is a subtraction problem. So come over here, A and B. Here. Conclusion, what goes in A, you're given, or you're given, your part A of your conclusion is the overlap piece. So where it overlaps, that goes here. That's from G to H. So once again, I've got GH congruent to GH, congruent to itself. Now that I have 2 longer segments and they overlap here, I'm going to take this piece out of both of them and then see if my remaining 2 parts are also congruent. So I've got my reflexive step. I'm pointing out what I'm taking out. And then B, I'm going to take it out. So I'm going to write my 2 segments here on the side. This is my work section. So I'm going to write down FH here and GI here. Now, if you're struggling with this, just think logically. Would it make sense to add this into both of these or take it out, subtract it? It's already part of them, so adding it again wouldn't make any sense. So we're going to subtract it. So minus GH and minus GH. Now I'm going to get my final 2 pieces. So when I take FH and I remove GH from it, what's left? FG. Let's do that again with GI. GI minus GH is HI. Hopefully you can see it's kind of the piece that stands alone. So outside of the overlap, what's left? HI. Looking at FH again. What's outside of the overlap of GH? FG. Okay, so then these 2 new pieces I made, those are going to go right here in B. So now I've got FG is congruent to HI. And then my reason, seg, because we're working with segments. And then we got a postulate. And then we ask ourselves, did we add or subtract here? We subtracted, so it's a subtraction postulate. Remember too, when we work with subtraction, we start with a bigger piece, and then our final answer is going to be a smaller piece. So make sure that is genuinely true. Is FH bigger than FG? Yes, it is. So we did do subtraction. Whereas with addition, you start with a smaller piece, and then you end up with a bigger piece. So if you have FG, and then we ended up with FH, did we get bigger? Absolutely, so it's addition. So I want to compare these two real quick, and I want to add another note. So here we looked for that overlap. We know it's subtraction. Up here, this was not an overlap. It's just a gap. So we look see they have the same gap in between them. This gap tells you addition. So if you want to kind of like a word to kind of trigger this response of, okay, if I see this, this is the postulate I'm using. Gap here, overlap here. Gap or overlap. It's kind of the name of the game here. All right, hopefully that helps a bit. Let's look at the same idea but with angles. Our last two, reflexive angle addition and reflexive angle subtraction. All right, so let's take a look here. And let's say we're given that angle 1 is congruent to angle 3. All right, I'm going to color code. I'm going to go back to my green and blue this time. Okay. So angle 1 congruent to angle 3, I'll make it blue. So angle 1 is here. Otherwise known as angle ABD, where 1 is inside the vertex. And remember what I told you before, when you outline your angles, don't just outline the sides. Remember, angle is the sides and the space in between. So I'm going to draw that curved mark from one side to the other, so that I'm looking at this angle. And that's really important in these problems. Angle 3 is here. It's really important to do it in these problems because visually this can get a little messy if you don't draw the loop. And here's why. Because it looks like I've also outlined angle 2, but I didn't outline it at all. It just happens to be in between the two. So that's why this curve symbol really draws my attention to 1 and 3 and not to 2. All right. So here we look, and we've got angles 1 and 3. They're separated. They don't meet. They don't touch. They're their own angles. But in between the two, we've got this angle 2 here that they both share. So this is going to be kind of my standalone angle. For angles, this will be my gap, if you will. It's kind of hard to highlight over it from this point. So, but angle 2 is kind of just sitting there by itself. So this would be my gap. So from here, I'm going to do some work, and I do have some space here, so I'm just going to put it here this time instead of down here. Put my work. Okay, so I'm going to write both of these out on their own equation. So angle 1 here, angle 3 here. And then since they're by themselves, and they have this gap in between, I'm going to do addition. So I'm going to add, I'm going to write out my conclusion and reason first. Might make a bit more sense. So the gap that they share is angle 2. So that's the part that I'm going to state is congruent to itself. And my reason is reflexive. So reflexive is when you point out that something is related to itself or equal to itself or congruent to itself. Now I'm going to add this to both of these. So angle 1 plus angle 2 and angle 3 plus angle 2. So when I add these together, what do I get? So let's take a look individually. 1 and 2 are both of these together. So when I do that, I'm going to need to form an angle that has both of these inside of it. So it's going to be angle ABE. Angle ABE, or EBA if you prefer. And we have to use these because if we did ABD, that's just angle 1. And if we did ABC, that's all 3 together. We just want 1 and 2. So ABE. And let's repeat with angles 3 and 2. 3 and 2 are right here. So we'll be looking at angle DBC. Or if you prefer CBD, that also works, but both of these. Okay, these two new angles are what I'm going to put in my conclusion in the second step. So that goes here. So step B, these two are congruent. Angle ABE plus angle DBC, or sorry, I don't know where the plus came from. is congruent to angle DBC. Sorry about that. Angle ABE is congruent to angle DBC. And then this time, so again, we're looking with angles. So angle, and then we have a postulate. So to fill in what this is, we've asked, did we add or subtract here? We've got a gap, so we should have added, and that's what we did. So angle add. All right, last one. Let's look at the opposite of that, the reflexive angle subtraction postulate. Let's say this time we are given angle ABE is congruent to angle DBC. So let's color those in real quick. And this time I'm going to use purple. So again, I'm going to outline these, ABE, it's this here. And don't forget that loop symbol, that's very important in these problems. Okay, so ABC, ABE here, and then DBC, DBC. And then don't forget that loop. Now I don't want to overlap these with my marker because then they'll just blend together. So I'm going to come out a little bit further so that I have two separate loops. So I'm going to draw from one side to the other. So C and here. If I had drawn it the same idea, then these would have just overlapped. And visually speaking, I wouldn't be able to see that obvious overlap. The way I drew it, you can obviously see they overlap here at angle 2. So I'm just going to kind of fill that in with the pink. You're like, okay, there's where the overlap is. So here I have an overlap. Remember, with the overlap, we're going to subtract, because we're going to take this piece out of both angles and see, okay, are the remaining pieces still congruent? All right, so let's do some work here. I'm going to go ahead and fill in my conclusion and reason. Before I do the work, I want to clearly point out what the common angle is that I'm going to subtract here. So again, that's where the overlap is. The overlap is at angle 2. So once again, I'm going to point out that angle 2 is congruent to itself. And then the reason, once again, that's the reflexive. I don't know why I did that. That's supposed to be an A. I'm making mistakes all over the place today. Sorry, that should be an A. And these are both B's. Okay, so now I'm going to write both of these down. So angle ABE, and then angle DBC below it. And then once again, we've got an overlap, so it's subtraction. And then I'm subtracting the common angle, angle 2. All right, to figure out what's left, I have to go to my picture. So let's follow ABE, that's this angle here. And then if we look at the visual picture here, so I'm basically looking at this here, 1 and 2. If I take out angle 2, which angle is left? I'm just looking here. If I take out 2, what angle is left? Angle 1. If you prefer to use letters, you could also say angle ABD or DBA. Those all work. I prefer the numbers, it's just slightly easier and less writing. And then let's repeat with this angle here, DBC. So it's where I have 2 and 3 put together. So this angle here. And then if I take out the overlapping portion, angle 2, which angle is left? If I take out angle 2, which angle is left? Angle 3. Once again, if you prefer letters, you could say EBC or CBE. Those all work. So now I'm going to take my remaining angles, and those are going to go into my second step. So now I've got angle 1 is congruent to angle 3. And then my reason, remember we're working with angles, so it's going to be an angle postulate. Now is it addition or subtraction? We had an overlap here, so we should have subtracted, and we did subtract, so we're good. So angle subtraction postulate. And I just do SUBT for subtraction. Remember to just kind of check yourself, especially if you're not confident in this yet. Since we're subtracting, we should start with the bigger piece and end with the smaller piece and make sure that's true. Is ABE bigger than angle 1? Yes, it is, so we're on the right track. Okay, that's it for the postulates. I do want to take a few more minutes and break this down a little bit more if you still feel like you're not getting it. So if you feel great about this, then you can go ahead and end the video here. I'm going to go back to the segment ones and add in some actual numbers so that I can kind of convince you that this does genuinely work if you just aren't believing me, which is completely fine. So just a reminder, in your actual problems, you will not have numbers. These are all just kind of abstract, not very concrete. So we're just working with general segments, not number values. But if we attach a number value, this is how it would look. So let's look at number 8 here with the segment addition postulate. So we started with F, G, and HI, and they're congruent. So let's say if I said that FG is 8, then HI would also be 8. And then let's say that GH here is a 3. So what I'm doing with these equations is I'm taking FG and HI, which are both congruent, they're both 8, and I'm adding the same thing to both of them, in this case GH, which is 3. If I take two different segments, they're both length 8, and I added the same piece to it, so it's going to be the same thing, hence the same length, will my final pieces also be the same? Yes, they will. So it seems weird because we're working with different lengths here, but since they are matching here, all 3 of these pieces are going to be the same. So that's why this idea works. Now let me show you once again, but with the subtraction. So I'm going to do that again up here next to it. Let's say in this problem, once again, FG and FH and GI are congruent, meaning the same. So let's pretend that they are both 12. And that's going to be kind of awkward to write, so I'll just put it here. So they're both 12. And then let's say our piece, GH, is 5. So let's say G to H is 5. So once again, I'm taking two different pieces that are the same length. They're both 12, they're congruent. And then I'm going to remove the same piece from both of them. In this case, GH, I remove GH from both of them, and that GH is, I'm saying it's 5. So once again, if I do this, where I take two congruent segments and subtract the same thing from both, will the answers be the same? I sure hope so. So once again, even though all 3 of these pieces are different, since there's matching across the board, all of these are going to be the congruent. The starting segments are congruent. We're taking the same thing out of both of them, so then the ending segments are congruent. So hopefully, if that didn't make sense before, hopefully with the numbers now you can kind of see a little bit more of it. Personally, I always preferred concrete examples with numbers before you started throwing letters at me and just general statements. So I know that this will help some people because personally that's how I've always thought as well. Just a reminder, your actual problems will not have numbers. This is just to convince you how and why it works. All right, if you have any other questions about this, feel free to reach out to me or whoever your teacher is. Otherwise, I'll see you guys in class. Bye.